If differentiation has ever felt like a list of random rules you just memorized, today we're fixing that. By the end of this video, you'll know what differentiation actually means, why the rules work, and how to use them confidently in A-level exam questions. Let's start from the beginning. Differentiation is how we find the gradient of a curve at a specific point. You already know the gradient of a straight line is change in y over change in x, but a curve doesn't have one fixed gradient. Its steepness changes as you move along it. So what differentiation does is zoom in infinitely close to one point on the curve and find the gradient of the tangent at that exact point. That gradient is called the derivative. You'll often see it written as dy by dx, or f dash of x. Now for the basic rules. The most important one is the power rule. If y equals x to the power n, then the derivative is n times x to the power n minus 1. In words, bring the power down to the front and subtract 1 from the power. For example, if y equals x to the 5, the derivative is 5x to the 4. If y equals 3x to the 4, the 3 stays. You multiply it by the power, and you get 12x cubed. Next, constants. The derivative of a number with no x in it is 0. For example, d by dx of 5 is 0. That's because a constant graphs as a horizontal line, and horizontal lines have gradient 0. When you have multiple terms, differentiation works term by term. Suppose y equals 2x cubed plus 4x squared minus 7. Differentiate each part separately. 2x cubed becomes 6x squared. 4x squared becomes 8x. Minus 7 becomes 0. So the derivative is 6x squared plus 8x. Now let's step up the difficulty. If two expressions are multiplied together, you need the product rule. If y equals u times v, then the derivative is u prime v plus u v prime. In words, differentiate the first and multiply by the second, then add the first multiplied by the derivative of the second. For example, y equals x squared times 3x plus 1. Let u be x squared and v be 3x plus 1. Then u prime is 2x and v prime is 3. Putting it together gives 2x times 3x plus 1 plus x squared times 3. Expanding carefully, that simplifies to 9x squared plus 2x. If you see a bracket raised to a power, that's the chain rule. The idea is differentiate the outside, then multiply by the derivative of the inside. For example, y equals 3x plus 2 all to the power 4. First, differentiate the outside using the power rule to get 4 times 3x plus 2 cubed. Then multiply by the derivative of the inside, which is 3. The final answer is 12 times 3x plus 2 cubed. Now let's put this into an exam-style question. Find the equation of the tangent to y equals x cubed minus 4x at x equals 2. Step 1 is differentiate. The derivative is 3x squared minus 4. Step 2 is find the gradient at x equals 2. Substituting gives 3 times 4 minus 4, which is 8. Step 3 is find the point on the curve. Substituting x equals 2 into the original equation gives y equals 0, so the point is 2, 0. Step 4 is use the straight line formula y minus y1 equals m times x minus x1. That gives y equals 8x minus 16. Finally, common mistakes. Don't forget to reduce the power in the power rule. Don't forget to multiply by the inner derivative in the chain rule. Always differentiate each term separately, and only drop constants when the entire term is constant. To recap, differentiation finds instantaneous gradient. Use the power rule, constants go to 0, add term by term, and apply the product and chain rules when needed. It's structured, predictable, and with practice, automatic.